Welcome back aspirants on MacTech 40, and today we will see the question 1C of paper 1, and this is based on heat transfer, a steady state heat transfer conduction. Okay, so what the question says, as you can see here, that is a hollow sphere of inside radius 3 centimeter. So I am writing simultaneously here a hollow sphere of radius 3 centimeter. So inside radius Ri is 3 centimeter given to us. Outside radius 5 centimeter given. RO 5 centimeter is given, and it is electrically heated at the inner surface with a constant heat flux. Heat flux, that means heat transfer per unit area, Q double dash. I am writing here as a 10 raised to 5 watt per meter square. Okay, it is given. The outer surface of the sphere dissipates heat into the surrounding at air 40 degrees Celsius. So surrounding temperature of air is 40 degrees Celsius, and by which mode it will lose the heat? By convection. Okay, assuming the thermal conductivity for the sphere material K is given to us 15 watt per meter Kelvin, and H value for air is given as 400 watt per meter square Kelvin. We have to find the outer and inner surface temperature of the sphere. Okay, now first of all, here there are some assumptions that we have to take in the consideration. That is, here is a hollow sphere like this, and one consideration assumption is steady state. We have to write in the exam. Okay, steady state we have taken one dimensional heat transfer. Third one is radiation is neglected, and fourth one will be no internal heat generation. Okay, so whatever heat that is supplied on the inner surface, heat flux, so that heat flux, the same amount of heat flux will be at the outer surface will be there, and in this the heat flux is the same as heat loss by convection. So heat loss by convection is given by HA delta T, but A is here accommodated in heat flux. Okay, so H into delta T. Delta T is what? Outer surface temperature minus ambient air temperature. Heat flux is what? 10 raised to 5 is equal to H is what? H is 400 given, outer temperature minus the ambient air temperature is 40 degrees Celsius. So when you solve this, it will be get 250 here. This 2 will get cancelled. Here it will become 3000 by 4, that is 250 plus 40 is equal to outer temperature, and outer surface temperature is 290 degrees Celsius. Okay, so this is the first answer. Second is inner surface temperature. Now we have assumed it is a steady state. So whatever the heat flux and one dimensional heat transfer is there, so whatever the heat flux from inner surface to outer surface has the constant heat flux, and there is a resistance, and the heat transfer from inner surface to outer surface is by conduction. Okay, so heat flux, it is given by K delta T of R1 R2 into R2 minus R1 divided by R1 R2. Why here I have written? Because generally for heat transfer through the sphere, it is given by 4 pi K R1 R2 divided by R2 minus R1. Okay, R1 is inner radius, R2 is outer radius, but here we have to take the flux. So 4 pi r1 r2, it should be on other side. Okay, so we can write like this r1 r2, or we can multiply or divide denominator like this. So our equation will become like this. So here r1 r2 will get cancelled. So only equation we have, that is heat flux is equal to K delta T. Delta T is what? Inner surface temperature minus outer surface temperature divided by R2 minus R1. R2 is what? 5 centimeter, and it is 3 centimeter inner radius. Multiply by 10 raised to minus 2 to convert into meter. So heat flux is what? 10 raised to 5 multiply by 5 minus 3, 2. 10 raised to minus 2. K is what? Thermal conductivity 15. Ti minus outer temperature is what? 290 degrees Celsius. Just we have find out. So here it will become 2000 divided by 15 plus 290. It will become our inner temperature. Okay, so when you solve this in your calculator, you will find as the inner temperature is 423.33 degrees Celsius. So this is the answer, all to answer. This question seems like very easy, but today we will solve another question, that is here. Describe the briefly working principle of vortex tube refrigeration system, mentioning its advantage and disadvantage. Okay, so what is the vortex tube refrigeration? First, let me draw here on full screen. So it is a, we have solved one numerical also in thermodynamics. Okay, so tomorrow I will solve that numerical. Okay, first today I am explaining the theory behind it. This is one chamber. This is known as vortex tube, and here there is a one slider is placed over that. With some adjustment mechanism, it can move to and fro to control the mass flow rate from this side. And here one nozzle is there. Here one nozzle is there, and the nozzle is the working principle is based on this idea came from generally a cyclone separator. You might have seen the cyclone separator that is used to clean the air. For example, the air with dust particle is coming like this and flowing like this, and all the dust particle which are in heavy size, due to this collision on the wall, it will go down, settle down, and the air will be flow out from bottom to top. Okay, so they have experienced that while operation of cyclone separator, the air which is striking on this wall having the higher temperature. Okay, but the air which is leaving the surface, sorry, leaving from the center, it is having the lower temperature. Cold air is getting out. So the same principle here used. The air is, the nozzle is provided, one section is there, and the nozzle here from the air is provided. The angle of the nozzle is such that the air will enter here at a tangentially. Okay, and it will be flow like this. So it will be flow like this, it like whirls. Okay, and it will strike continuously on the wall, and here we will get a hot air. Okay, this is a hypothetical device, but at some level this can be, this is currently using in industrial application also. So what happened in this, the air enters tangentially from the nozzle. The angle is, nozzle angle is set such that the air will enter tangentially, strike here, and make a whirl. If you cannot imagine, so just take a, just do an experiment, and at your home you take a larger diameter pipe and take a small ball, maybe of cricket or tennis, and just give it the spin on the surface, and you will see its flow will be like circular. Okay, this like this Archimedes whirl. So here the same whirls were created, and hot air will be passing out. So by adjusting this stopper, so we can accumulate the how much amount of hot air we have to pass. Now when the air is strike and continuously on the wall, so it will continuously get the heat and momentum, so it will get hotter. But the amount of heat that is striking over here on this point is known as point of stagnation. Okay, point of stagnation. So whatever the kinetic energy is converted into pressure energy, and the pressure at this point, let us say point C. So pressure at point C will be higher than atmospheric pressure. So what happened? The air will try to move in the similar manner, in this whirl manner, but the diameter of this whirl is quite small. Okay, so what happened? As the pressure is high, so air always has a tendency to go from higher to lower pressure. So there whirls are created, and whenever it pass through, so this outer whirl, this is hot air whirl, it try to absorb the energy from this. Okay, because of the high enthalpic value. Okay, we will see the numerical tomorrow, so that you will get the idea better. So what happened whenever as this cold air passes here? Okay, so its temperature is going to decrease because the energy content that is taken by this hot air. So air will become more hot, and cold air will be come out from this place, because the only opening here it is provided, because here this side is the hot air is going. So here we will get the cold air. Okay, at this point here we will get cold air. Now what happens? This is the working principle. The air is coming from the nozzle. So hope you guys clear this. So what is this application in industrial application where simultaneous heating and cooling is required? Now the advantages and disadvantages. Advantages there is no mechanical power is required. First, okay, the only power that required is to move this plunger to and fro, and if the accumulator is provided there, then it require the power. Otherwise, it will not require any mechanical power. No moving parts, so the less friction is there. Easy to construct. Okay, so these are the some advantages. But and simultaneously hot air will also get hot, and cold air we will get simultaneously. These are the advantages, but there are some disadvantages also. The disadvantages you can see from the figure, that is there are too much entropy generation is very high compared to conventional cooling method, and the rate of cooling is low compared to our conventional air conditioning system. Okay, and here there may be a chance of mixing. And third one is efficiency will not be as, not very less, but not too much that our require case. So efficiency is less. Fourth one is there is maybe chance of mixing of hot and cold air there, and here in this whirlpool portion. Okay, and the losses, internal losses are there, as I told you, because this is a whirlpool tornado, this is like vortex motion. So there are some chances of internal friction. Okay, so it may tend that you will not get sufficient cold air. Okay, and the last disadvantage is mass flow rate. are dependent on area. Okay, if this area will get choked, then this is the maximum condition is achieved. More than that you will not get. Okay, the regulation is quite okay. So these are the advantages and disadvantages. Hope you guys clear this. Tomorrow we will see the example of vortex tube. Okay, a thermodynamics example while taking the enthalpies. So you will get the enthalpy values, so you will get the exact idea about the how heating and cooling is work. So okay, so stay tuned for tomorrow. Till then, keep studying, stay focused.